I'm going to do a short video lesson on how to draw Lewis dot structures. And Lewis dot structures are used to represent the placement of electrons in covalently bonded compounds. So we're going to do a tutorial on how to draw Lewis dot structures. There are a number of different rules that we need to follow when we're trying to draw these structures. And the first rule is to find the total number of valence electrons in the molecule. Valence electrons, as you may remember, are electrons that are in the outermost shell of the atom, and they're the ones that are involved in bonding. So anything in the first column has one valence electron, and the second column has two valence electrons. We skip over the transition metals, and then these guys have 3 valence electrons, 4 valence electrons, 5 valence electrons, 6 valence electrons, 7 valence electrons, and 8 valence electrons. And the importance of this is that atoms are stable when they have 8 valence electrons. So each atom technically wants to have 8 in order to be as stable as it can possibly be. So they'll either gain and lose electrons in order to have a full outer energy level, and that is what occurs in an ionic bond, or else they'll share electrons in order to have a full outer energy level, and which is what occurs in a covalent bond. So if we want to draw a Lewis dot structure for the molecule CF4, the first thing that we want to do is figure out how many valence electrons are in this molecule. So carbon has 4 valence electrons, and each fluorine molecule has 7 valence electrons. So since there are 4 of them, there's a total of 28 valence electrons from the fluorine. So altogether, the CF4 molecule will have 32 valence electrons. The next step is to arrange the atoms so that there is one central atom with the peripheral atoms around it. So again, if we're talking about CF4, generally the first atom in the compound is the central atom, so we would put it in the middle, with the fluorines, which are the peripheral atoms, around it. We now want to put a pair of electrons between each pair of bonded atoms. So again, here's our CF4 with the carbon as the central atom and the fluorines as the peripheral atoms. And we're going to put a pair of electrons, so we'll draw 2 little electrons. Between each pair of bonded atoms. Now, another way to represent a pair of electrons is by using just a single line. So another way to do this would be to draw it in this way. I'll erase the one that's here, or I'll erase the pairs. And just to make the diagram look a little bit neater, I'm just going to draw lines. Again, a line represents 2 electrons that are shared. So if we look at this structure, the carbon in the center has 8 valence electrons, and that's because each pair is made up of 2 electrons. So the carbon has 2 from this pair, another 2 from this pair, which is 4 total, another 2 from this pair, which is 6 total, and another 2 from this pair, which is 8 total. So the carbon is stable because it has 8 valence electrons. The next step is to fill in the octets of the peripheral atoms. And what that means is to make sure that each atom has 8 valence electrons so that each one is stable. There are a couple of exceptions to the octet rule that you want to note as well. Helium is stable with only 2 electrons, beryllium is stable with 4 electrons, boron is stable with 6 electrons, and elements that are in periods 3 through 7 can have more than 8 electrons because they're so big. So if we have our original CF4 with the carbon in the center, is the central atom, the fluorine surrounding it, bonds between the carbon and the fluorines, and now we want to fill in the octets of the peripheral atoms. So that means we want to make each fluorine, since those are the peripheral atoms, have 8 electrons. So I'm going to fill in the octets by drawing 6 additional electrons around each fluorine. And when we draw 6 additional electrons around each fluorine effectively will have 8 because it's sharing the 2 with the carbon in the middle. So here we can see that each fluorine is stable because it has 8 valence electrons, and the carbon has 8 also because of the bonds that it has to the fluorines. So whenever there is a bond, the bond represents 2 electrons that are shared between the 2 elements that are connected by the bond.